Welcome, everyone. The event is now live. John, please take it away.
Thanks, Paula. Hi, everyone. Welcome to the AWS Security Best Practices Summit. This event was organized by the hardworking folks at AWS Insider and Virtualization and Cloud Review, who have brought together some of the best independent experts on today's topic. Many thanks to our sponsors, eCentire, the authority in managed detection and response, and Sumo Logic, empowering digital business through real-time analytics. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief of Application Development Trends, and I'll be your moderator for the first of 3 information-packed sessions. But before we get started, I need to go over a few housekeeping details. Each of today's sessions is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way within the next few days. Each of today's sessions will be followed by a 5 to 10 minute Q&A. You can type your questions into the Q&A box at any time. Please feel free to add your questions as they occur to you throughout the summit. We'll do our very best to get to all of them. Our sponsors, eCentire and Sumo Logic, have provided some extra resources that can be found on the right-hand side of your screen. Please take a moment to check those out. As you leave the summit today, you'll be asked to take a very short survey. Please take just a moment to share your honest opinions. Our editors read every comment and they help to shape our future events. And last but definitely not least, at the end of the 3rd session today, one lucky attendee will be receiving a Breville Barista Pro stainless steel home espresso maker. It's a state-of-the-art coffee shop-grade appliance for creating authentic espressos and cafe-inspired drinks. This gorgeous machine includes an integrated conical burr grinder and a thermojet heating system that achieves the optimum. Can you tell I'm drooling? Sorry. It achieves the optimum extraction temperature in 3 seconds. But you must be present to win, so stick with us. Now let's get started with our first session, Top Enterprise AWS Security Best Practices. For this session, we've called on Stephen Smiley, AWS Solutions Architect at Intervision Systems. Mr. Smiley leads the Intervision's AWS consulting program, where he focuses on enabling innovation by making security fundamentals accessible and actionable instead of a roadblock. A former military intelligence officer, he balances strategic and tactical thinking to help his company's customers accomplish their objectives. You are in for an awesome session. Take it away, Stephen.
Hey, good morning. Thanks, John. I got to figure out how I can be eligible for one of those coffee makers because you guys give away the best gifts here. Hey, so thanks for having me today. I'm very excited to talk about a topic that is, I think, really important, right? AWS security, particularly in an enterprise environment. A little bit about me, I lead projects for Intervision Systems, and we do a number of things around, comprehensive AWS security, migrations, cost optimization, and development of serverless applications. All, very exciting topics. And if you have any questions and follow-up, please feel free to reach out to me on LinkedIn or Twitter at Stephen Smiley. But without further ado, let's get into it here. So today we're talking about AWS security. So I want to cover some of the fundamentals, and then I've got some categories here that I've broken down for AWS security maturity. And then we're going to talk about some of my just top actionable tips of what should you be doing right now if you're not already doing them. I want to point out that what we're covering today is kind of my personal way of thinking about AWS security. There's lots of other ways. There's a cloud adoption framework. AWS has a well-architected framework. And, there's CIS. There's lots of different ways to look at it. And I think all of those are helpful, but I've distilled different perspectives of those into something that's helped me actually come into a new environment, figure out where are we, what do we need to do, kind of by priority, and then actually resolve those issues. So I'm happy to share that with you guys here today. Starting out with the fundamentals, cloud security. First, no discussion of cloud security would be complete without mentioning the shared responsibility model. AWS does a great job of securing everything that they possibly can on their end, but you are ultimately still responsible. It's your environment. You have to be aware of what AWS is doing. You have to turn on the configurations appropriate to your situation. So don't think that AWS is either completely secure or completely insecure. You share that responsibility. And I got to tell you, it's so much easier with AWS and in the cloud than it ever was before. Another fundamental here is that you should refactor your security architecture during a cloud migration. This is something that I've learned over many cloud migrations. It's just not the same. And it's a great opportunity for you to improve your security architecture. So as you figure out what your controls are going to be, you should really consider your new environment and don't just lift and shift exactly what you've got. Now, it's okay to lift and shift some parts of it or plan to improve things later, but you really want to think about what those implications will be, and so you don't get stuck doing old things in a new world. Another thing to think about here is you should be considering threat detection and response really early. You don't want to wait until you're forced to think about that, right? You don't want to wait until you've somehow determined that things are compromised. Think about what could go wrong here. How am I going to detect that? What services, what controls, what am I going to do to detect that? And what will my response be? Now, you can't obviously do that for everything without really exhaustive effort, but you should be thinking about your highest priority stuff and be prepared. You don't want to be caught later with an incident and you just didn't know how to respond. And the last bit here is you really need to build security into every layer that you're doing. Cloud makes it easier than ever, but it's still not out of the box, right? And when we're talking security here, we're going to talk about lots of different areas, and it's not just encryption of data, right? It's like every step of your environment should have this security built into it, and AWS really does make that pretty easy. So we're going to talk about what that looks like. As I talked about before, I've broken down the different categories and functions into my own categorization here. But largely they come down to identifying what you've got and protecting it, and then detecting, responding, and recovering. That aligns with NIST's cybersecurity framework. And we're going to look at what each of these kind of functions looks like. So before we do that, here's an overview of all the different functions and capabilities that I've got aligned to a maturity level, right? So on the left side, we've got a minimal capability level. And you see that there's a few things that I really think you should be doing in a minimal environment. But then as we go to the middle, we've be an improved level. I think you need to start thinking about a lot more stuff in order to be mature at that level. And then on the right side, I've got some advanced things that is really going to be environment dependent, depending on how your environment operates and what your team looks like and what your requirements are. And then as we go to the next slide here, I'm going to show the coverage that AWS has with their native services for each of these things. So green here is where I feel like AWS has great coverage. And then as we go into kind of yellow and orange, it's where you're going to look for some third-party stuff or some advanced configuration. And I've been keeping this up to date for a couple years now. And one of the things that's been really happy to see is that AWS has now covered everything at that improved level, whereas it used to have some gaps. And so this just kind of proves that AWS has reached the point where you really can do everything with just AWS services. The one thing that I think on the left there is still yellow is about account management, and we'll talk about that because I think you do need some extra help there. Okay, so let's get into it. The first topic here is account management. Account management really is just knowing everything that you've got, right? And with AWS, this is not always super straightforward. AWS has this concept of accounts where there's strict boundaries between those accounts. And many years ago, most people would operate just everything within one account. But then AWS was like, well, actually, the most secure thing to do is to separate your workloads by accounts where there's strict security boundaries. But that meant that some people ended up with dozens or even hundreds of accounts. And they might be under one AWS organization where they're all kind of grouped together, but they also might not be. So that they might be in several organizations, or you might have rogue separate accounts. But ultimately, at a minimal level, you need to maintain an inventory of your account. And you need to have some data about those, like the root email addresses, their account IDs, and points of contact. If something happens in this account, who am I contacting for it? If that person leaves, who's their backup, right? You should identify shadow accounts, right? If there's accounts out there that you're not aware of, but they've got even development workloads that might have, your proprietary data in them or proprietary, development stuff, you should find out about those, and you should have those at least inventoried and hopefully bring them under control. One tip here is that you can contact your AWS account manager and say, hey, can you give me all the accounts that are under my company's domain? Now, people might be making accounts under a personal email address, and you can try that too. The best way to do that is to look for expense reports. Get with finance and say, is anybody expensing AWS accounts? Because I've seen that, especially, salespeople, they don't want to go through your internal processes to create an account. They'll just make one and then expense it. Well, who knows what's in there? So identify all those, inventory them, and bring them under control. And for all of those accounts, you should really be controlling their root access. Think carefully about that email address that it's tied to and the account phone number that is configured on the account. The email address can be used to reset the password, right? You just have to go and say, hey, I forgot my password. So you really shouldn't have those email addresses go to any individual. That should go to some sort of a locked down mailbox where you've got some controls around resetting the passwords. The account phone number is also important because that can be used to bypass the multi-factor authentication that's set to the account. And of course, you should have MFA on your on all your root users. So think about those paths and make sure that's all accounted for. And since you've set those root email addresses to something that people are not going to access on a day-to-day account or a day-to-day basis, how are you going to get notifications about operations or security issues? The answer is set alternate contacts on each of those accounts. Probably a distribution list of some sort. Operations, I think, is great to go to a team of people who's operating the workloads in there so they can see what's going on. And security, depending on how you're set up, I like my security notifications to go to a central security authority, some team that can then say, okay, we know we're taking care of this. But don't let that just go off into a black hole. Okay, so then at an improved level, you really should have a tiered account management structure, and you should be applying some restrictions, right? So AWS Organizations allows you to group these accounts into organizational units, and that's helpful just at a mere organization level, just so you know which ones belong to which. But also, you should be applying restrictions on subordinate accounts. Use service control policies to protect key controls, right? So prevent disabling logging and alerting, right? CloudTrail. Block new ways of creating access to the internet if that's your requirement, right? You can explicitly deny things with a service control policy, like creating a new internet gateway. You can also deny access to non-approved regions, right? If you don't need people ever operating in Singapore, just block that, right? Just make it not possible for those accounts to do it. Service control policies can even block the root user of that subordinate account. So you can block the root user from doing any actions except for like changing their password, right? So you still want to protect it, but service control policies are super powerful. I will warn you that up until recently, it was pretty difficult to figure out that a service control policy was blocking you. So you want to communicate what those policies are. Otherwise, developers will be like, I don't know why. Why isn't this working? I'm just getting access denied, but I don't see any policies in here. I'm administrator. So just communicate what those policies are. Okay. So now you've got an inventory of all your accounts. Let's talk about how are we managing human access into those accounts, right? At a minimal level, we need to think about root access, right? Those root users should really just be used to set up, less privileged IAM users or roles, preferably single sign-on. But, just use root for that and then lock root away. You should be requiring multi-factor authentication. These days, that is standard, but you should be thinking about that at a minimum for all privileged access into AWS, any user access to sensitive or confidential data. And then I also think that you should be thinking about any accounts that represent official communication, so that you don't get compromised and have somebody, damage your reputation just through false official communication. At an improved level, you really should be thinking about fine-grained user permissions according to least privilege. Now, everybody says they want to do least privilege, but it's, of course, hard in practice. And in AWS, it is difficult. But there's a few things that will make this easier. So in particular, you should just be auditing access and removing unused credentials and permissions. So as a consultant, I go into lots of environments. And one of the first things I do to determine how well this environment is being taken care of is I'm going to go look at your IAM users and roles and see when they were last used. And there's inevitably, there's IAM users that haven't been used in 600 days, 700 days. Why? Why would you have that access sitting out there with a mystery access key, a password, no MFA? Remove those, right? Go through your accounts, remove unused credentials. And then additionally, go through and say, what are these users actually doing? What permissions can I remove so that if they were compromised, there's just less risk? The best way to do that now is to use AWS Access Analyzer, which can actually review your CloudTrail logs and generate a policy that only allows the actions that a user has performed within a specified time period. So you give them administrator during a development period and say, okay, I'm willing to accept that risk during this time, but then now that we're going to production and I don't expect you to be making any broad changes, now I'm going to scope down your policy. That helps a lot with reducing risk. I also highly recommend using AWS Single Sign-On. This service will help you completely remove IAM users for humans. Connect Single Sign-On to your IDP, whatever that is, Azure AD, Okta, wherever your identities come from, or just use it standalone. That's even good enough if you don't have another IDP. And then you can create permission sets that will be provisioned as roles into many accounts. It can get a little tricky here because if you have many, many accounts, how do I allow one team to manage permissions for just their accounts? And that is actually possible by tagging those accounts and then creating permissions policies that say, let these people change users in these accounts, right? So it gets a little advanced, but that is possible through attribute-based access control. And that's what we've got here in the advanced section. So attribute-based access control, many services support this, not 100%, but if you can tag resources and then have IAM policies that say, allow actions, but only on things with these attributes, that's pretty powerful, especially if you've got particular use cases that require it. And then the last one there is adaptive access control, which AWS does not support, but if your identity provider does, it can evaluate your endpoint security posture or location or behavior. That's great too, so that no one's logging in and making changes if there's a high risk, connection. Okay, so now that we've got human access figured out, what do I do about machine access, right? Service account. I think it's really important to separate these in AWS because, as I said, that your users shouldn't be using human users shouldn't be using IAM users. I think it's acceptable to use IAM users for your service accounts, especially if they can't support IAM roles, which some things can and some things can't. But if you do have IAM users for machine access, it's just really important that you scope down their permissions. And this is where that access analyzer is going to help a lot, because if you've got some external tool, in fact, one of the things that I noticed from external tools that try to tie into AWS is they often ask for very, very broad access. Well, I might start with that, but then observe what they're doing in the first 30 days and then scope it down using Access Analyzer. And that means that I just reduce the risk of some credentials that I actually don't have full control over because that's a third-party tool. You should also be thinking about where do those credentials live, right? So we never want to embed credentials directly into code. We should always be configuring applications to retrieve them programmatically. The easiest ways to do this is with Secrets Manager. If my application needs to pull database credentials or something, have that in Secrets Manager, but never let those credentials just sit out in the open in clear text. Okay, so and then at the improved level, start thinking about even more fine-grained permissions using resource keys, for example, saying, okay, you can call S3 get object, but only on these buckets, right? And really scope those down. And then, of course, wherever possible, generate temporary credentials instead of giving long-term credentials like a password or an access key. This is possible through Secrets Manager. It can get you a time-limited credential, or using IAM roles that have a built-in expiration. So it depends on what service you're trying to use, but always look for those kinds of capabilities and prefer them. Okay, so we've got our accounts inventoried. We've got our human access figured out and our machine access figured out. Okay, how do I protect my infrastructure that I'm hosting here? Some of this infrastructure is going to be meant to be public. Some of it's not. In today's world, where we try to think about things in terms of zero trust by default, that distinction may not be as important, but we still are going to start with our minimal level here as limiting our resource exposure to the public internet. This, unfortunately, can be more tricky than you think, right? So every week, somebody publishes a report about how they found publicly accessible Elasticsearch clusters or RDS instances or things like that. So don't be one of those people. Think about the access paths to your infrastructure. This has gotten better, particularly with the VPC reachability analyzer. So you can use that reachability analyzer to say, can this reach an internet gateway, right? And you can scope that down to specific ports, protocols, paths. Think about how that's how your resources are exposed, because if they can't reach you, it's going to be a lot harder for them. Maybe not impossible, but a lot harder for them to send you, malicious traffic. And then, even within your network, you should start thinking about your network topology. What resources need to talk to other resources, and limit those, only as necessary. One of the things that we're starting to see a lot more of is, in the cloud at least, is central traffic inspection. So AWS Network Firewall can provide that capability, and third-party things can as well, third-party firewalls, particularly with recent improvements to VPC and the network and just generally network capabilities. So it previously was difficult to provide central inspection because you couldn't have a route in your route table that was more specific than your VPC, but now you can. So you can say, I've got two subnets in a VPC. Well, anytime one subnet tries to talk to another subnet, it still has to send its traffic through my firewall. So that can be pretty powerful for not just firewalls, but also like IDS or IPS. But really that's kind of at an advanced level, I would say. For the most part, if you just effectively use security groups and network access control lists and route tables, you'll be limiting traffic only as necessary. And if I'm an attacker, that's going to make my job a lot harder to scan around and move laterally within your environment. Another one I want to call out here is access to instance metadata services. So IMDS version 2. This is a whole topic unto itself, but an EC2 instance can get some information about its environment through this metadata service. And in particular, if that instance has permissions through an instance role, it can get an access key to use those. If you have a vulnerability in your EC2 instance, like it's a SQL injection, for example, and some malicious user can pull that access key, then they can extract that access key and use it somewhere else and get the permissions of that instance. So IMDS version 2 makes that much more difficult because it will enforce some authentication between the instance and AWS. So you should really be requiring that and enforcing that across your entire organization. That's something that we're not seeing nearly enough of, and as unfortunately, if that were enforced, many compromises would not have worked. So that's a strong one. Also, endpoint vulnerability scanning. So AWS Inspector is the go-to service for this within AWS. Obviously, that there's third-party tools that have been around for a long time, but AWS Inspector has actually matured a lot. I think they increased its version number to 2. It can provide continuous scanning now, not just kind of a point-in-time scan. And if you've got that configured, you can have that automatically scan anything that comes up, which is pretty powerful. And then I want to point out one other advanced thing here, which is just limiting your deployments to automated technologies, right? So in the on-prem world, we used to do a lot of SSH to our instances, to manually apply patches, do a lot of manual administration. In the DevOps world that we've got now, we just know better. We know that if I disable SSH, then somebody just won't be able to use SSH to get in, for example, regardless of what they've got. AWS Systems Manager can make this a lot better by you can still use SSH, but it uses the agent on your machine. You can now, with Fleet Manager, even remote desktop into a private subnet, right? Or an instance in a private subnet without any openings. And so these things are much better at securing that remote administration. And then, of course, if you're just hosting a web application, you probably don't even need SSH at all. Just replace your instance with a new instance with a new version, and redirect the traffic, right, using a blue-green deployment or something like that. But just disable those services used for manual administration altogether. Okay. One of the things I'm pointing out here at the very bottom of this slide is that endpoint protection and intrusion detection is something that's not very well covered by AWS. We will talk about threat detection at the AWS management plane, but if you are running, big fleets of EC2 instances and endpoint protection, intrusion detection is a priority for you, there just isn't an AWS service that covers that super well right now. I see a question here from Sandy. Can you repeat the vulnerability management piece? So vulnerability management, AWS provides AWS Inspector, which will help do endpoint scanning, and that is a very powerful service. So there's a couple ways to do it. One is through continuous scanning of your instances as they're deployed, and that works, but it just involves a lot more cost because you're going to be paying for an inspector all the time across all of your instances. Another way that I like to do it is I like to build a pipeline. So if I'm creating an AMI, an image for my EC2 instance, I can have Inspector scan that image during its creation and only allow successful creation if it passes Inspector's checks. And then I don't necessarily need to scan it continuously once it's deployed. I know that anything that has been promoted to production has been scanned by Inspector. And so as long as I disable any ways of accessing that later, right, then I'm not worried about that being tampered with in production. If I do suspect that something was tampered with in production, somehow someone exploited a vulnerability in my application, what I'm going to do in that case is I'm going to disconnect it from the network, pull it into a forensic, snapshot its data for forensic analysis, and then I can do analysis on that later. But I'm not really worried about continuous scanning of that because I'm not going to be doing in-place updates. So I'm hoping that answers your question, Sandy. But would I still do a weekly scan? That really depends on your risk posture and requirements. I don't think that would hurt at all. I think that especially if you need to provide assurance to somebody that you are maintaining compliance, then yes, that's great. And then you get those reports and you can feel comfortable about it. Yeah. Okay, so I've got my infrastructure protected. What about my data? In some discussions, those things are put together because they're both protection. But I want you to start thinking about them separately because you're going to need some different controls around data in AWS. In particular, we talk about fine-grained access policies. Well, AWS supports resource-based policies, not just identity-based policies that are mostly around data. So KMS keys, S3 bucket policies, stuff like that. So things that protect your resources. I think those are really, really important to get right. Even if I've got administrator in the account, but I've somehow got a resource policy that's denying access to particular S3 buckets that we know have sensitive data, then that administrator can't access that data without somehow removing that resource policy first. And so then I can detect on that or enforce it with a service control policy, right? So think about your data, how you're protecting your data specifically. At a minimal level, I want you to think about selecting the right storage services and configuring them appropriately, right? So when we talk about security, we're not just talking about confidentiality and integrity, but we're also thinking about availability, right? So will my data be available when I need it? Think about replication across availability zones or regions as needed. S3 is, of course, the best, the best example of this because I can configure cross-region replication of an S3 bucket and make sure that is very, very resilient and available. This does apply to other services as well with your EFS, EBS, so that's available, but it really just depends on your requirements. AWS Backup is a great service for backing up that data across regions, or it's possible to back them up across accounts if that's what you need. So think about your requirements and if you're meeting them. Let's see. We talked about some fine-grained data access policies, specifically with resource-based policies, and really, I think one of the ways to help this is to enforce a tag policy. So through AWS organizations, you can create a tag policy that says, all my EBS volumes need to have a tag of, retention policy, something like that. And then it needs to have a value that says, how long do we expect to keep this? And it also needs to have a tag of data classification. And you should have a data classification scheme that says, hey, this is, completely unprotected. We don't care about this. Okay, this was sensitive. We don't want it getting out. And then maybe something really sensitive that's extremely, protected, whatever your scheme is. And then use that tag policy to scan across your organization and say, which resources don't have this yet? And then if they don't, let's go and create those. That alone will help you get an idea of what data do I have and what's at risk. And then you can create policies that say, only these kinds of users can access data at these levels, right? So that can be very powerful for protecting your data. I also want you to think about data encryption keys and really separating the users who have the ability to administer a key versus use a key, right? You don't really want that to be the same people if possible, because then somebody can decrypt all your data and then re-encrypt it with something else, change the key. It's a good opportunity for separation of responsibilities there. And then thinking about key rotation policies so that this is if you're using customer keys that you're bringing, you want to limit the impact of a single compromised key so that it's not applied to all of your data. I also want to call out Amazon Macie here. When Macie launched a couple years ago, it was expensive, it was difficult to use, and a lot of us in the security community recommended against using it. It's gotten a lot better. I think you should take another look. The costs have reduced, its utility has improved, and so if you're not doing some automated discovery of sensitive data, Amazon Macie is definitely something to look at. Okay, logging and visibility. This is one that's gotten better in just the last month or two. So have CloudTrail turned on across all of your accounts using an organization trail, and check out the new service of CloudTrail Lake, which will make it a lot easier for you to query those logs when the time comes. In the past, we used to recommend setting up Athena with particular indexes so that you could query that data. CloudTrail Lake basically just does that for you. And if you don't have another tool that you're ingesting your logs into, at least AWS has you covered now. I'm gonna speed up here a little bit. Let me know in the questions if there's something I'm missing. I'm running a little behind. Threat detection. So I think that at a minimum, you should be doing threat prevention capabilities through AWS config rules, right? So particularly weak configurations that you know are not right, let's detect those through config rules, and you can set up some automated remediation. At a more improved level, Security Hub does come with some improved standards that you can use to enforce configuration across your organization. And then I highly recommend using Amazon Guard Duty across all of your accounts. What we talked about earlier with the instance metadata service, where an access key can get pilfered out of EC2, well, Guard Duty can detect that. So have that in place, and you'll feel a lot better. There's some advanced things here with threat detection, and those are really environment dependent, whether that's, loading that into a SIM system, setting up fake tokens that an attacker might use that'll alert you, or do AI threat hunting. All of those things require much more advanced configuration, but we can definitely talk about them in a follow-up if you'd like. Incident response. The main things here is just be prepared to have some incident response plans. Be prepared to access your environment if there's an incident going on in there. That might include root, but think about, if my root's compromised, can I have an IAM role that lets me in? Think about what those paths are going to be, and so that if somebody does get in there and they get some access, they can't just totally block you out. As much as possible, automated remediation of weak configurations is a good idea. AWS config rules has you covered there, but the truth is it's really hard to predict all of those things. So that's going to be environment dependent. And my recommendation there is just empower your developers to configure their own automated remediation. And that's kind of the DevSecOps way, right? That team is responsible for their own security. And then recovery. So the main things here is you want to think about, what are your disruption scenarios, right? What would happen? What could happen to me to disrupt my environment? How would it fail? How would I recover? Think about this ahead of time. I think the most significant thing you can do is define and deploy your cloud infrastructure using code, right? Infrastructure as code. Back up those configurations and really protect them. If someone accessed your Git repository and deleted all of your applications and infrastructure code, what would you do? Where would you start, right? So if you, and in even worse, let's say you didn't define all your stuff as infrastructure and you were just clicking in the console and someone got in and broke all of that, you would have nothing to start with. I mean, you'd have to start all over from scratch, basically. The best way to do this is to write your application in code, CloudFormation, CDK, Terraform, stuff like that, and then protect those very carefully and be prepared to deploy them again. So I think that's an important security consideration. And then I want to talk about high availability versus fault tolerance versus disaster recovery. Again, this comes into the security topic of availability, but these words get mixed around a lot. So high availability refers to level of performance that's higher than normal, right? So that might be 99.9%, right? 3 nines uptime, but that still allows some amount of downtime. And I think that in most cases, this is acceptable for your environment. But think about how much downtime you would accept and architect accordingly. But then let's talk about fault tolerance. So fault tolerance is a next level of this, where you expect the system can continue operating properly if there's an event component in the event of a component failure. So here you're saying that failure is unacceptable. True fault tolerance is actually much more expensive and much more difficult than most people think about. AWS does a great job of making their services highly available and fault tolerant, but the workloads you build on top may not necessarily be unless you really architect them that way. And then disaster recovery. So this is more about the policies, your tools and procedures to keep your vital systems alive when HA and fault tolerance didn't work. So my analogy here is that a spare tire on a car is high availability. All right, you pop a tire, you pull over, change it, and you're back on the road. That's good enough, right? If you require fault tolerance, then it's more like a aircraft that has redundant engines. I can't just pull over and change my engine in the air, so I need redundant engines, redundant hydraulics, active, multi-site architecture. And then disaster recovery is an ejection seat out of that helicopter, right? Everything else didn't work, but I got to keep the pilot alive. So these are your offsite backups, critical credentials, logins, and a staff plan for how am I going to handle a true disaster. So I've got a few top actionable tips here, but let's jump into any questions that you have. We've got about 10 minutes left. I'd love to answer any questions that you have for me. Thank you.
Thanks, Stephen. Let's see here. Let's go with, this is a question from Paul. He's asking, can you explain what happened to Sony and what AWS did to make sure that does not happen again? Are you using multi-cloud within AWS network of data centers or allowing outside providers to interact with AWS? Kind of a long one. The Sony attack was what, 2014, I think. I'm trying to remember exactly what happened there. There was a denial of service attack. I'm not sure I remember exactly well enough to address that question. Let's see. Can you explain what happened? Yeah, it was a network breach in 2014.
Network breach.
A hacker used Amazon's Elastic Cloud compute service to attack the online entertainment system.
Oh, so they used it to create a denial of service attack. I see.
Yeah. Yep. Yes.
Okay, so I think that since then AWS has improved their backbone significantly to both withstand denial of service attacks and prevent them from happening within. Of course, I'm not an AWS employee. I can't speak for them, but my understanding from everything I've seen since then is that they will shut it down. They can detect a denial of service attack coming in or out very quickly. So I don't think that is a significant risk in the future. Are we using multi-cloud within AWS or allowing outside providers? Multi-cloud, of course, everything's multi-cloud, right? Like if I use Azure Active Directory to authenticate into AWS, boom, I'm multi-cloud, right? If I'm using Salesforce and I've got workloads in AWS, boom, I'm multi-cloud. What I'm not doing is I'm not doing multi-cloud for a particular workload. I'm not trying to architect a web application that can load balance across Azure and AWS, something like that. I'm not doing a Kubernetes cluster that has, workers in multiple clouds. To me, in order to do that, you would have to water down your workload really significantly to only take advantage of the lowest common denominators. I think that you would end up architecting something that was much, much more brittle than if you just focused on doing one cloud well. Generally, the recommendation is if you are looking at doing a multi-cloud thing, first try multiple regions within that cloud, because just architecting something that can span Virginia and Oregon in AWS would be difficult enough. Just thinking, okay, what are the failure modes? Well, what if, how am I going to redirect traffic from one to the next? I can do that with DNS, but what if Route 53 is affected? That alone can be difficult enough. So I generally recommend doing one region really, really well and having a disaster recovery approach that is well thought out, right? So you can have a pilot light in another region or potentially another cloud. You could have a warm site if that's what you need, but that's what I would recommend. I'm not doing active multi-cloud workloads. I'm hoping that answers. I know that's long-winded, but I'm hoping that answers your question.
It's a long question. Okay, Donnie is wondering, with a lot of people afraid of moving things to the cloud, and with recent pointing to the AWS outage of services, how would you now sell cloud to these fearful people?
That's a fair question. I don't think that outages are significant enough to make me want to go back to a data center. I think that I think we underestimate how difficult it is to run a data center. And there's a lot of graybeards out there who are like, well, I've been doing it for 20 years, so I figured it out. Well, are you going to be able to hire new talent to do that for the next 15 years? Can you guarantee that you'll be able to replace your hardware, right? I just think that the value proposition of cloud is definitely still there. And the outages, although they can be painful, aren't that bad. If you architect your workload to withstand that outage, I don't see it being an existential threat to your business. Hopefully your customers or business can withstand people taking a walk for a couple hours and then they come back. So I don't think it's that significant these days, but we'll always keep an eye on it, because if it gets worse, then, hey, maybe we'll all repatriate back to data centers, but I'm not excited to do that.
That leads kind of neatly into Victoria's question. What capabilities does AWS not cover well right now?
AWS does a great job staying within its own ecosystem, right? But if you need intrusion detection systems, especially if you want them to span, you still got a data center, right? And you want the same IDS, rolling up reports across multiple things. It's just not something AWS can do, right? You'll have to go for a third party for that. AWS does a great job at doing disaster recovery within AWS, but if you need to recover to a different place that's more challenging, right? So it's the capabilities that span things across AWS. One of the other services that I guess we didn't talk about in depth here was Incident Manager. I'm a fan of Incident Manager, in fact, where I can automatically trigger incidents based on events within AWS, and then manage the communication of that, keep logs and notes. I think that's all great, but if it really only works if my team is accustomed to working in AWS, if AWS is only a part of what we do and we have to be in many other places, I think third-party incident management systems are just better suited for that right now. But give it a year because that's still a new service. So AWS has done a great job of closing the gaps. In particular, that CloudTrail Lake. I used to complain a lot that CloudTrail was great at logging everything, but when it came time to query, I wasn't. You're not ready to do that, right? You can put them into CloudWatch logs, where the query capability is really limited. I can't do it across two dimensions in CloudWatch logs. I can only say, this one dimension. I can create a Athena table on demand, but most people are not prepared to do that and to learn that on the fly. So the answer was like, well, you have to go send all your logs to Splunk or some other tool like that. And I think that was a big headache. CloudTrail Lake makes that a lot better, and I'm actually optimistic that they'll continue to improve that with some more standard queries for common investigation scenarios, because right now we're kind of building those for ourselves. Yeah.
Okay, we're just about out of time, but let's squeeze in one more question. This one from Daniel. Do you think it is foolish for the industry to put all their cloud eggs into the AWS basket? Any competition on the horizon that could dethrone Papa Bezos?
Papa Bezos. As much as we all like Papa Bezos, right? I think the trick is that AWS really is the leader right now. They are doing better than the others. I know there's different opinions, and I'm not going to fight people too hard on those. But I've worked in Azure. My brain doesn't wrap around it. It's not. I don't feel like it's developer centric. I think it's focused on people who are used to Microsoft and Windows and clicking in a console. And I don't think that it's made to help you develop fast. But that's just one perspective. And I think that you could. I think if you were brand new, you didn't have an investment in AWS, you could use Google Cloud, but you're going to run into kind of much more poor support compared to AWS. It's not going to have the breadth of services, but there's lots of developers that are going to be just fine without AWS. But I think the trick is that at this point, they're just well ahead of others. I don't think that it's a huge risk for like the industry, however, because there's always going to be probably dozens of good cloud providers that provide the core services that you need. So AWS is always, I think, going to have to be afraid of them, right? There's going to be lots of providers that can do things. I mean, like, let's look at Cloudflare, for example, right? So they've got a new object storage R2 that competes with S3, particularly on cost. They've got a great backbone network. They've got Cloudflare workers that can, do serverless functions at the edge. So I think AWS still has to be afraid of their competition. And there's also going to be competition that's just around hosting containerized applications, just kind of a basic thing. So I don't think it's that foolish for us to do it because I don't think it's going to risk the industry. Yeah.
Well, it looks like that's all the questions we have time for this session. Many, many thanks to Stephen Smiley for a great session, and to our sponsors, eCentire and Sumo Logic, for making it possible. We are going to take a very short break, but we'll be back for our second session, AWS Cloud Data Security and Recovery Best Practices, presented by Carlos Rivas, Senior Solutions Architect at Intervision Systems, and moderated by my colleague, the editor of Virtualization and Cloud Review and news hound of the Baskervilles, David Rammel. Now would be a great time to check out those extra resources on your console provided by our sponsors. And remember, during today's third session, we will be giving away this gorgeous Breville Barista Pro stainless steel home espresso maker. But you got to be here to win, so stay tuned. Back in a few.
Welcome back to our second session. David, please take it away.
Okay, welcome back, everyone. Thank you for being here. Thank you to our speakers, my fellow moderators, and of course our sponsors, eCentire and Sumo Logic, for underwriting this summit and allowing us to bring you this great content. I'm David Rammel, editor of Virtualization and Cloud Review, here to moderate the second session of our summit called AWS Cloud Data Security and Recovery Best Practices. Our speaker for this session is Carlos Rivas, a senior solutions architect at Intervision Systems, who helps community colleges move their traditional data centers to the cloud. Over the course of his career, he has worked with several large telecommunication providers managing and configuring network devices using numerous tools and languages, including Java, Groovy, Python, Perl, and PHP. He's also a cloud computing instructor for LinkedIn Learning and Udacity. Carlos, it's great to have you here. Please take it away.
Thank you so much, David. I am happy and to be here with you guys. Plenty to discuss, so let's just jump right in. We're going to be talking about what I do for disaster recovery in AWS, and then we're going to switch gears just a little bit to backups and encryption. And I also consider backups kind of a simple way to refer to disaster recovery. So backup is like the lowest level of disaster recovery, I would say, like non-real-time version. So we're going to talk about that a little bit. And then at the top of the hour, again, we're going to be talking to you guys, just Q&A. If you have any questions, I'll be more than happy to answer your questions. With that, one little announcement before we get into disaster recovery. I'll have another session right here. It's going to be about disaster recovery in multiple cloud environments. I heard that was part of the previous presentation with Stephen, that some people might be interested in a multi-cloud or hybrid cloud disaster recovery scenarios. And I'll be discussing that later this month, so stay tuned, and I hope to see you in that session. And with that out of the way, let's talk about the specifics about disaster recovery here in AWS. Before we jump in, let's establish what disaster recovery really is. As I mentioned, a backup is essentially the lowest level of disaster recovery. Is when you have to manually go get your data, put your server back online, and after doing a restore procedure. However, these days, for most businesses, that's not good enough. You need to have a way to be back online as soon as possible when something happens, especially if you are, capturing revenue by the minute, by the second, and every moment your application is down, you're missing out on those transactions. I heard in the previous session that you guys also mentioned something about the recent outages in AWS. Yeah, that's something that's also a concern. You need to be prepared for those scenarios, especially, AWS keeps growing and growing. So every time they have even a tiny outage, that's going to affect tons and tons of companies that are dependent on those services, right? So back to our slide here. What I consider a cold standby is when you have, an application that you have, let's say, a snapshot of your server. Let's say that you have several Windows servers and you take a snapshot of those and you just keep them there, maybe update them, every few hours, every few days, depending on your needs. And what we do with that is we wait. We simply wait for our application to fail for whatever reason, and we get some sort of notification, and then we can bring those servers to life from the snapshot, perhaps in a different location or somewhere where the failure is not affecting the environment. A step up from that will be a warm standby, which means you have more of a system that is actually almost ready to go. Perhaps you're backing up your database in real time or near real time, perhaps every few hours. So you have your data ready to go, and perhaps you only need to bring up the server and connect it to that database in the event of a disaster. The top of the line, in this case at the bottom of the slides, would be the hot standby. It's when you have a system that is pretty much ready to go. In the case of AWS, that would be, let's say, a copy of your system let's say, in the West Coast, if your primary is in the East Coast. And in that scenario, like I said, you would be pretty much real-time backing everything up, assuming that at all times you will have that failure. And that's something that I heard in AWS from the very beginning, is that when you're designing a system as a cloud solutions architect, you just have to assume that things will fail at some point in time, and you just have a design for it. And that design considers the failure as part of the everyday operations. So when it happens, you don't have that much to worry about. One example of what I just mentioned would be this RDS database service provided by AWS, which I really like in terms of disaster recovery, because essentially you can set it up by itself to do a primary database that goes along with a standby database. So this is something that happens behind the scenes. You don't need to worry about it. As long as you're paying AWS money, you will get this functionality. Again, this is comparing to our hot standby, for example. This will essentially back up your database near real time. Something to point out here is that this will have a Route 53 DNS entry or host name pointed to this database. And what happens is when the primary database fails, the IP address will be flipped over from the master to the standby. You wouldn't even know anything happened. So that's why I really like this service in terms of disaster recovery, because you will not even know something happened. The IP address will just flip, and you will continue hitting the same host name from your application, and your application will have no idea that there was a switch over to the standby for whatever reason. So yeah, this is a really great example of how to design for disaster recovery. Of course, I'm still talking about, you see at the bottom it says AWS region. This is still a single region, and that's kind of a bad thing to be in the same region, because usually when something bad happens in AWS, it will probably affect an entire region. So, going back to my favorite example is that you would like to have a copy of this, like I said, in a different geographical location, like the West Coast or something, just so that if something does happen, you at least have that geographical protection for natural disaster and things like that. A step up from there, which really takes up the complexity up a notch, but it does mention what I just said, which is having Route 53 at the very top, and then fail over to an exact replica of your system. Although this slide says active-active, meaning that this would be essentially the most expensive disaster recovery there is, because essentially you have two copies, two live and active copies of your system. So again, it doesn't get any more expensive than this. But of course, if your use case, merits something like this, then by all means, go for it. One side effect or advantage of using this type of setup is that your disaster recovery can also work as a load balancing or workload distribution. So meaning that you don't need to have your disaster recovery just sitting there. You can actually say, hey, I want 50% of the traffic to go to this side and 50% to the other side. And especially if you have this spreading out over, let's say, of an entire region, an entire country, you can also do geo-based routing, meaning that you will send your users to whatever system is the closest to them so that they'll experience the lowest possible latency. Actually, I think I can show you something like that. Let me try to pull up my screen share. This is my AWS console here. I'm going to pull up Route 53, see if I can show you something, what I mean. Yeah, I'm going to try to create an entry here. I'm going to go to one of my domains and click on Create Record. So, let's say a very popular name like db.mydomain.com here. And for your database, and of course you would put in the IP address, whatever it may be of that database, or if this was a CNAME record, you would probably point it to the internal host name. But what I want to show you here is that you have these routing policies. You have the geolocation that I just mentioned. So whatever person tries to hit this domain name, db.something.com, it will send them to whatever copy of this is closest to them. So if I choose geolocation, I'm presented with several options here that I can add based on that, right? I can also choose failover. Failover, you have primaries and secondaries, so you can do all this behind the scenes, and the person will never know. They'll just hit your host name and connect to the service. They don't need to know that all of this is going on behind the scenes. Another cool feature that we have from Route 53 is the ability to set up a health check. So you don't even need an additional program to notify this domain manager that the application were down or that the server went down for any reason. You can just put in a health check right here, and everything will be taken care for you. So that's Route 53 there for you. It's a really neat tool for the purpose of disaster recovery. We usually don't think about this as the DNS management tool as a disaster recovery, but if you put it this way, it's certainly a useful tool in your arsenal to recover from a disaster. Going back to our slides here, let's move on. This is another way to look at disaster recovery. This slide that we're looking at is the AWS landing zone. And it's where you would have various AWS accounts or AWS environments, as you might want to call it, to separate the specific functionalities that apply to you. So in this case, you would have an account for shared services. To me, shared services usually means transit gateway to route traffic, and perhaps an Active Directory or something like that for the purpose of authentication. You would also have separate accounts for logs. Logs usually are considered sensitive data, so you don't want to make that available to your entire fleet of servers or all your employees and things like that. The same goes for the security account. You want a very select few number of people to have access to your security account. So this type of setup is great from the point of view of what we call blast radius, meaning that if you do get a bad actor in your environment, it will be much harder for them to switch from one account to the other, because every one of those switches will require additional credentials that they may not have. So it reduces the blast of the problem, right? So this is more of a security perspective to the disaster recovery, because if you're trying to recover from a disaster, you want it to be contained as much as possible. So this is a great starting point. And by the way, you can do this entire setup with a couple of clicks. Just look into AWS Control Tower. If you're wondering where I'm getting all this information from, is not just out of work experience. There's actually documents provided by AWS that you can read on that contain pretty much everything I have discussed so far. And that would be, the number one is the AWS Well-Architected Framework, which is a document that's updated all the time with this type of information, because they keep evolving that setup there. So, you can always get the latest by referencing this document. I believe the address is aws.amazon.com/whitepapers, and this is where you can get all this stuff. Oh, and let's not forget the disaster recovery of workloads on AWS, which is a document specifically written for disaster recovery scenarios. So, like I said, they draw a lot from experience, so you can get all this information pretty much from there. Now let's talk a little bit about backups. Backups is one of those things that really never ends, and it applies ever so slightly different to everybody. It's not just as simple as saying, "Oh, I just want to switch to this tool or that tool." Well, like I said, most of us have slightly different scenarios. Some people just need to worry about a few gigabytes. Some others have in the order of terabytes, and that changes the approach entirely. Some people, they need it to be off-site. You need it to be, you have an on-prem backup, but you also want it to be in some data center far away, things like that. So everybody has a different view on backups. The very first tool that I would like to point your attention to is AWS Backups, which is a product that they're evolving to cover as many services as possible from the AWS catalog of services, and that they want to cover pretty much everything with this one tool, so that way that people that are responsible in your organization for managing backups, they just really need to learn one tool. In the past, it used to be that, I need to make a backup for a database, so you need to be a specialist in that area, like, okay, how do I create this database backups? How do I manage these? And then you would have to focus on the tool. In this case, once you separate the backup task from the tool itself, whether it's a Windows server or a database or something like that, it's a little better, if you're using just this specific tool. Actually, you know what? Let me bring you back to the screen share. I'm going to pull this up here and switch to services. I'm going to look for, it's right there, AWS Backups. I'm going to show you a little bit how this tool works. I don't have any backups here, because this is just my personal AWS account. But I can show you, for example, if I click here on Create Backup Plan, the first thing you want to notice is that they already have templates. So that gives you an idea of how to use this tool. So if I choose one of the templates, the very first one, it says daily and 35-day retention, daily, monthly with 1-year retention, daily, weekly, monthly with 5-year retention, and so on. The retention period, of course, is the point in time where the backup will be discarded or rotated out. And yeah, you can just essentially create something like this. Actually, let me just pick one to show you. And yeah, essentially, you can select all these options here. Let's give it a name. Below backup. And then create plan. And the interesting thing about this is that, like I said, they're essentially removing the backup from the tool. Like, this separation is really nice, because now you see here it says assign resources. So it doesn't really care what you're trying to back up. As long as you put it here in the list of resources to be backed up, it will know exactly what to do. So if it's trying to back up a Windows server, this tool already knows how to do that, right? It uses tags. So always remember to tag your resources in AWS, because not only for billing purposes, but you can use it as an identification for the purpose of backups, for example. You can just say, hey, I want to back up only the resources in production that has the name tag, or I shouldn't say name tag, because it would be more, let's say, an environment tag, and then, call it production, for example. Anything that you have that, has this type of setup, it will be included in the backup, for example, whether it's a database, a Windows server, or anything in between that is supported by this tool. So it's a really nice way to make sure that you're backing things up, and without having to, okay, now I need to become an expert at backing up EFS or backing up EC2 or backing up RDS. You don't need to know that. This tool will do it for you. So it's a great way to simplify AWS in that sense. Now, if this tool is too much for you, let's say that your environment is just made up of just servers, right? You have some Linux servers or Windows servers, and that's all you need. You don't need an overkill tool for that purpose. You can just go to the EBS volumes part of AWS here and just, select the Data Lifecycle Manager. And this is a tool that can help you just back up the drives that are attached to your EC2s. Like I said, it doesn't matter the operating system. It could be Windows or Linux or whatever flavor you have in there. And, attach a policy to those backups, just like we saw, retention policy and frequency, how often you want to make these backups. And also you have the option of creating standardized AMIs as well with this. Now, why would you need to create an AMI or Amazon Machine Image? The reason is for disaster recovery purposes. So you would have this AMIs ready to go, which is essentially a snapshot copy of your server, typically a web server. Perhaps you're running Apache or WordPress or something in there, Nginx perhaps, and you have your server fully backed up. So when the disaster actually happens, you can go to S3 or just go to in this case, to the EBS volumes. And with that copy, perhaps in a different region, if your region is being affected, you can just take this data, or this snapshot rather, and spin up a new server exactly just like that. And then, of course, do the Route 53 setup that I mentioned earlier to point your host name to the new server, and you're up and running. Of course, as I mentioned, this is more of a way to do it that is very manual. Of course, this is not, I wouldn't consider this a hot standby by any means or anything like that. This is more of a way to recover that is a lot cheaper for sure, because you don't have like a real-time running copy of your environment. But this is great. You can still, if your company is okay being down a few hours while you do this process to recover, it's just absolutely perfect. This will certainly work for you all the way. Now, there are other ways to take care of backups, and this one in particular, called the Storage Gateway, is a way to perform backups that involves your on-prem environments. So let's say on premises you have a bunch of VMware environments, servers running. And these servers, of course, need to be backed up regardless whether they're in the cloud or not. They need to be backed up. So what do you do in this case? Well, AWS provides an appliance. In this case, an appliance is just like a little virtual machine or software that runs inside your local environment. You will deploy this locally. And then you can configure it just like you would configure any backup tool. And you say, hey, I need to back up this server or that server. You make your selections. And then behind the scenes, it will essentially communicate back to AWS, and it will essentially keep replicating your data near real time. Of course, this is going to affect your bandwidth. So, if you have a ton of outgoing internet traffic, you might want to consider that when selecting this tool. Perhaps you can set it up to only perform backups at night when the employees are out of the office or nobody's using that particular traffic there. But yeah, this is a great way to be able to back up to AWS without having to have much cloud expertise, because once this is set up, you're essentially backing up your on-prem data center to the cloud without really having to understand how any of this stuff works. It just essentially works. It's just a little bit of software, if you will, that just sends backups to the cloud in a way that is user-friendly for you. There's still another way. I'm not going to give you any specifics here, but there's another way to do it, and that's using third-party software. There are software that's essentially dedicated to this. One thing I do like about third-party software, and I'm probably going to mention it in a future session, is that you can configure it to be multi-cloud. So if you're not, like, I'm not just going to back up to AWS, I want to have another backup of my servers going to Azure, for example. You can use third-party software that works exactly as I described the storage gateway for AWS. And this software, what it's going to do is essentially just send the data to, in this case, I'm showing Amazon S3 and Amazon Glacier for cost-saving purposes to send it to the cloud. But like I said, most software these days that perform this exact function, as long as you have the necessary network connectivity behind the scenes, it will allow you to do it in a multi-cloud way, which is absolutely great. Just being able to have that peace of mind that, AWS can go down. Perhaps it affected your service or perhaps not. And then you say, okay, I'm not going to wait for these people. I'm just going to go to my other cloud provider and I'm going to spin up my servers there using this other secondary copy that I'm making. However, as it was mentioned in the previous session, the trick with that, or the problem rather, is the DNS entry, right? You have your DNS hosted somewhere. And for that reason, hackers just love doing denial of service to DNS services. So, let's say you're using Route 53, and that's where your, like I said, database.yourbusiness.com, that's where it resides, that name, right? And if that Route 53 server goes down, it doesn't matter whether you're running in Azure or Google Cloud. If users can't get to the host name, they will not be able to reach your backend service. So it's just something to keep in mind that it's really hard to be 100% protected. And I'm sure that's going to come up here in the Q&A at the end. So just something to keep in mind that as a cloud solutions architect, you can only do so much before disaster recovery has some single point of failure somewhere, right? That's just part of the deal, I guess, right? Speaking of Glacier, since I just mentioned Glacier, this is a service that I don't want you to overlook. It's really easy to overlook Glacier because it's just there. It's not very glamorous. Amazon doesn't really advertise this very much, and I'm sure why. It's because this is essentially the cheapest per gigabyte service that they offer in terms of data protection. So in this service, essentially what you're doing is capturing your data and saying, I'm willing to use cold storage because I don't need disaster recovery to be real time. I'm okay with waiting 2 hours, 4 hours, that's fine, to be able to fully recover from a disaster. So in that case, Glacier is an option for you to consider at all times. Now, why is that? It's because most of us these days, businesses have been going in the digital age now for decades now, right? So some of us will have not just gigabytes now, we're moving into the terabytes and beyond, and it can get very expensive very quickly, especially if you have governance over your data that tells you, hey, these logs, by the way, you need to keep them for, 5 years. And you're required to do so regardless, just because this data contains X sensitive information, and there's a governance on it that says you need to have this retention policy no matter what. So, like I said, you can get into the terabytes very, very quickly. And hopefully, using a service like Glacier can help you there in the sense of, how can I get this into the fractions of a penny per gigabyte? So something to consider. And of course, when you're starting, and this is something that I see a lot because I work with a lot of customers that are moving to the cloud for the very first time, it's like, how do I start? Let's say that I'm something very popular, let's say 90 terabytes. How do I even begin to push that to the cloud? It is not practical to try to push something like 90 terabytes over a wire, right? It's going to take weeks, right? So in that case, you can just put a ticket with Amazon, and they'll send you via UPS ground or something. They'll send you a little box that looks like this. It's essentially a small computer with a network port that you can plug in directly to your local data center. And once you have this in your own data center, it will, using DHCP, it will pick up an IP locally. And once you have that IP, essentially it becomes an Amazon S3 endpoint inside your data center. Once you have this up and running, and you can verify in the display that it has that, hey, it's connected and it's pinging and it's fine, you can move your entire 90 terabytes over your local network, which in this case would be either a 1 gigi or 10 gigi connection locally, way faster, and there's no travel time, there's no routing or switching, it's just right there. And in that case, of course, you can load as much data as you need. I believe this comes in multiples of, I keep forgetting, I think it's 40 and 80 or something like that. So you may need multiples of these to move a very large amount of data. And yeah, once you load them up, just ship them back to Amazon, and this data will show up in your Amazon S3 bucket that you assign to this particular device. Once that data is on the other side, you can just keep it there on S3. Of course, it's going to get very expensive very quickly, but you can put a lifecycle policy to have it rotated to Glacier, and that's when the savings kicked in. Just to give you an example from my experience, I had an S3 bucket that was billing almost $1,000 a month. And just by applying a lifecycle policy to move that data to Amazon Glacier from S3, or rather to use Glacier storage class within Amazon S3, the bill went down from $984 to $53. So that gives you an idea of the savings by committing to cold storage. However, there's a little bit of a fine print that I need to tell you. Once you move to cold storage, you are committed to a 6-month contract there. You can't just be putting data in there and then deleting it the next morning. They're going to charge you for 6 months anyways. But given the rate of savings, going from $1,000 to $50, it's totally worth it. So if you never use a device like this to move data, it's something that you need to consider, and in combination with something like Amazon Glacier. Now let's take a look here. What else? Let's see. Oh yeah, I wanted to mention this one. This is the bigger option, the snowmobile. There are very few cases where you have to go past the terabyte scale. When you're moving like really, really large amounts of data. I just mentioned that some use cases need more than one of those little boxes. Well, you can just order a freaking huge truck that has a capacity to move 100 petabytes. So far, the only use case that I've seen for this is the one that AWS themselves presented, and it's a satellite imaging company, like where you're generating gigabytes of data by the second. So you get into the terabytes per day very quickly, and in that case, very easy to go past 1,000 terabytes, within a year, 2 years. And then at that scale, you need something crazy like this. But yeah, like I said, I haven't had the opportunity to see an actual real life use case for something like this, right? And, they actually wanted to intimidate people, I would say. They actually show a huge truck with the infrastructure over there at reInvent a few years ago. Let's talk about ransomware, only because ransomware is very, very tightly related to backups. So let's talk about that here for a second. So a ransomware is essentially somebody that connects to your environment, breaks in, and instead of, destroying your information, they just use their own encryption key. They encrypt your data. And then they say, well, you're never going to see your data again because it's now encrypted with our key unless you pay a ransom. So again, in this case, if you have a backup, well, you're safe. You can just say, I'm not going to pay anything, let them do whatever they want. I'm just going to lock down my servers or deploy them elsewhere and pull from my backups, and we're done. Except the problem is, what if this guy encrypts your backups as well? Now you're in trouble. So what do I do in this case? What's my solution? Your solution is something called an air gap, and this goes back to the slide that I mentioned, the AWS landing zone, right? In a landing zone environment, you have various AWS accounts that are completely isolated from one another. So an air gap is essentially a one-way connectivity where you can send your backup, say, to a backup account that nobody in your environment has access to, perhaps just the owner, perhaps only your production system administrator, something like that. A very, very tightly controlled environment that nobody has access to. And that's where you have your S3 buckets, your Glacier, everything in there. And, you can back up from everywhere in your environment and send stuff to this account. As long as this is not the account being hacked or, being put in a situation of a ransomware, you are fine. Well, you could argue, well, what if somebody encrypts my data and I don't even know that my data has been encrypted, and the backup system runs and sends the bad backups through the air gap to the backup account? Like, what do I do there? Because now my backups are encrypted. Well, to that, I would say that you have your backup is going to have a multi-version control, meaning that you can say, I don't want to restore the latest because the latest is corrupted. I want to restore from the previous day, for example. You could argue that that's something you could do if your backups are affected. But just know that the solution to a ransomware attack is to be able to have backups isolated from your main environment. So there's something to consider. This is what it looks like in a type of diagram form, where you have your various connections, various peers, and then you can send your data over the wall, quote unquote, in this case a firewall, or it's either a firewall or it could also be simply authentication based, meaning that there's no way to get in this account unless you have these other credentials that nobody else has. Just perhaps, like I said, one person only has this particular access. What else? Database. Talking about database, I mentioned that a little bit in the beginning. And yeah, it's essentially what I said, where you have a DNS entry at some point, and as long as that DNS service doesn't fail, which, Route 53 can fail, unfortunately. If that happens, then, okay, you're out of luck. But let's say the primary DNS lookups works. Because of the failover policy, the user doesn't need to know whether they're connecting to a primary or a secondary standby database. They don't need to know that, right? As long as that replication is going all the time. So when the primary goes down for whatever reason, that switch can happen behind the scenes, and everything will continue to work. So this is just kind of a recap of something I mentioned earlier, because this is if you memorize this design, you can apply it to web servers, for example. Let's think about that right now. Imagine that the DNS was pointed to a web server instead of a database. You would have a load balancer sending traffic to one another. The load balancer will detect that one of the web servers went down, and then will automatically route traffic to the other. Again, going back to the problem is that you will still have a single point of failure somewhere, whether it's the load balancer itself or the DNS manager, in this case, Route 53. So you can't make it perfect. You can get there as much as possible when you think about it, right? Now, when it comes to backups, let's say that you want to do database backups, but you're not really interested in AWS backup servers, or EBS volumes doesn't apply here. So what do I do? Well, the RDS service itself, it has its own backup service built in. So yeah, you can do the same thing that we discussed earlier. You can have policies, you can have snapshots, and those are version control, and version control is not the word. I think incremental is the right word to say. So instead of getting one huge snapshot every single time, it will just kind of calculate the difference in the backup and do an incremental backup based on the previous one. Those are also based on S3 storage, meaning that you can apply what I said earlier about using a Glacier storage. So if you want to have tons of backups of your database going, daily, going a year or more, you can do that and use the Glacier storage class within S3 to save money on those. Also, encryption is supported, but this is one of those cases where it's probably not to think about this in terms of ransomware protection, for example, because let's say that somebody gets into your database and encrypts the data inside your database, then unfortunately in that case, the backups will contain the corrupted encryption there. So yeah, that's just something that I wanted to mention there for you as well. Another thing that I really like about AWS RDS is the secrets manager, because obviously you want to be protected. You don't want to ever have to get to the disaster recovery or having to go to a backup or whatever. They have this little tool that will force you to auto-rotate your passwords. So this is great because that means nobody even needs to know the passwords to your database, because you can have this tool automatically change your password, I don't know, daily, every 7 days, every 15 days, and it will manage the password rotation for you, so you don't need to worry about that. Your applications will just ask Secret Manager for the credentials, whatever they may be at the time, and then use those credentials to access the database. So you don't need to worry about changing password, and this is one less headache for you because this software will do that for you automatically. Speaking of encryption, which I believe is the last point here that I have for you, it's very simple. It's just KMS. KMS is the tool for you when it comes to encryption. The reason why I mentioned KMS is because it allows you to bring your own key material. I know some people are paranoid to say, well, why am I going to encrypt my data with a key that's provided by AWS? Doesn't that mean that they have access to the possibility of decrypting my data? Well, if you are one of those individuals, you could say, well, use KMS, but I will provide my own encryption material. You can generate your own keys using some software locally and upload that to KMS and use it as your encryption material. KMS also has some really cool features to protect itself. So let's say that you have a rogue employee that goes ahead and delete the encryption key out of KMS. KMS will actually keep that key for a certain retention period. So it's not that simple as saying, oh, this key is deleted, now I need millions of dollars to be able to restore it. No, that's not the case. They have protection, and you can also provide temporary access to keys. So let's say that you have auditors or employees that need to be able to decrypt data. You can lend them the key for a certain period of time, and KMS will do the revoke at the end of the period. This is more or less the various flavors of KMS. You can just use it directly, and most services within AWS already use KMS, whether you like it or not, behind the scenes. They have a bunch of default keys provided for that purpose. And also the options that I mentioned where you can provide your own keys for the purpose of encryption. You can manage your own keys in KMS. So it saves you that trouble of having to have additional encryption software in AWS. All right, what actions can you take right now in case you're new to the cloud and you're not very well protected? As I just mentioned, just keep rotating those passwords. We usually get a little relax on this thing and not do it. I've seen API keys, going back 2 years, 3 years. People never change it. So yeah, keep this on top of your mind: password rotation and key rotation. And encryption, I know encryption adds a little bit of overhead. It slows down your servers and stuff like that, but you can never go wrong when it comes to security providing encryption. So the way I like to say it all the time is that it's best to have your data stolen and then be discovered that they can't decrypt it because they didn't steal the key than to have to think about like, oh my God, my data is stolen. Now I have to think about encryption. It's already too late. You never want to be in that situation. So I realize that it adds CPU consumption and it may slow down your system, but encryption is always nice to have. Same thing for backups. Same thing goes for backups. So just keep those backups at all time. Once a week is probably not enough for anyone. Even if you have a hobby account in AWS, once a week is probably not enough. Try to reduce your retention periods and just do daily backups or something like that, because that would be a lot more useful. The same thing goes for an air gap. You can have an additional account that builds directly to your own account, and that doesn't cost you any extra. Right? It's just they don't even charge any money at all for new AWS environments. So you can just right now go ahead and create an account and call it air gaps or call it backups or whatever, and send your data in there, and then just give that password or that access to one person, perhaps yourself, and then you would have that air gap that I mentioned as protection. And David, that's my presentation. So if there are any questions, I'll be more than happy.
Okay, great job, Carlos. We do have some questions, and we'll get to those in a second. First, I'd like to remind the audience that we can take questions up until about 5 minutes to the top of the hour in order to give you a short break before the next session. So please send them on in now. And let's go to the Q&A console and see what we have. We'll go first come, first serve. Carlos, if you want to follow along, we'll start off with a question from Imtiaz. Imtiaz asks, can you achieve better than 99.9% availability, say 5 or 6 nines, or special use cases for cloud deployments?
That's a great question, and it goes back to what we were talking about earlier, is that at some point in time, you have to have that one single point of failure that we all dread. So my advice there would be to find, there's something called these AWS Health Dashboard, where they show you the historical failure of services. So there are services that you can actually trust more than others. So for example, Route 53 as your DNS management, you can use that. And let's say you pointed to Azure, let's say you pointed to AWS, all that stuff going on at the same time, that should give you a very reasonable amount of availability. But again, it goes back to the same thing, that in this case that I'm just quoting, you're using Route 53 as your single point of entry, which becomes your single point of failure. So in that scenario, that right then and there, that will take away some of your nines in your availability. So it can get annoying at some point in time, having that single point of entry into your environment. But, like I said, it doesn't matter how many times you replicate all over the place. At some point, your users have to be able to find you, and that's when the single point of failure comes in. So as much as we love to hate AWS outages, it will happen. So something to consider when it comes to the availability that you're looking for. Perhaps having multiple entry points into your application could help. Like intentionally having a deployment in Azure, another one in Google Cloud, and another one in Amazon. But then your users will need instructions to understand that whenever this system is down, then go to the other one, right? So.
Okay, Carlos, I got to say, that's a truly great answer. That's very informative. Let's see if you can duplicate that. A question from Paul. He asks, does AWS provide its own CASB, Cloud Access Security Broker, and does it work with other CASBs from third-party providers? Now, I just did a little research, and I couldn't find an AWS CASB. So what do you have to say about that, Carlos?
In that case, yeah, I agree with you. That's not something terribly specific. However, I remember one scenario using a tool called Zerto, and that tool, even though I may not be answering because it's a question perhaps about security, but I'm going to answer in a disaster recovery type of way. There are tools already that consider hybrid cloud or multi-cloud options when it comes to being able to recover from a disaster. Again, this might not be the exact answer you're looking for because it's more this DR than security base. But yeah, AWS, to answer the question directly, no. There's no CASV right there. So.
Okay. I do see a lot of third-party offerings out there, though.
Yeah.
Okay. Let's move along. Next question reads, can I use AI or machine learning applications for fraud detection?
Absolutely. I actually have a customer that receives application forms from users, perhaps, let's say, scholarship applications. And those applications will have something like social security numbers and sensitive information like that. And that automatically makes those sensitive document, and therefore they become targets by hackers, right? And so in this particular deployment, the customer was asking, hey, we would like to use Amazon machine learning services to be able to detect when an application is being submitted in terms of identity theft. And yeah, we were able to do that. It's just a matter of training the machine learning service in AWS to be able to look for certain values that if this values doesn't match that, or the perhaps the birth date of the person is completely out of range from where it should be, mark it as fraud. And yeah, you can certainly do all those things using the AWS machine learning tools as a tool to prevent fraud.
Okay, great. Let's squeeze in one last question. How to detect EC2 launches to mitigate risk of cloud cryptojacking?
That's another way that I've seen that people are hacking into accounts. It's not to actually steal anything, or they don't want to do any damage. They just want to use the cloud environment to be able to start running applications to mine Bitcoins or something like that. In those situations, you probably don't have to do much because AWS is already looking for those patterns in their environment. So they'll probably find out long before you do that this is actually happening. But if you wanted to protect yourself in this case, I would recommend one tool, and that would be AWS Config, because that tool is specifically designed to look and monitor changes in your AWS environment. So in this case, it will find something and say, hey, there's a new machine in your environment. That already should be an alert for you that there's a new server in your environment. And this server is not one of the machines that you use. So let's say that you're used to running EC2 servers for web servers and things like that, and all of a sudden you deploy a machine that has a GPU and it's all kinds of memory and hard drive. So it's a huge machine that is out of the norm. You can get a notification from AWS Config sent to your email or to your cell phone, and then you can take appropriate action if this is not something that you started yourself. So, say, hey, I want to be notified, but I also want to send a termination to this machine, or perhaps just suspend it until I figure out what's going on. Perhaps it was somebody else that's also using my environment that attempted to do a legitimate launch. If not, you have that option of, putting things on pause until you figure out what's going on. So that would be AWS Config.
Okay. Well, it looks like that's all the questions we have time for. So thanks again, Carlos, for a great presentation and answering those questions.
Thank you. It was awesome.
Okay, everyone else, stay tuned. We're going to take a short break and be back at the top of the hour for our third session, Hottest Third-Party Products, and the giveaway of our high-end Breville Barista Pro stainless steel home espresso maker, for which you must be present to win. So hang tight, take a break, check out those resources in your console,